Hi, we are Silesian Phoenix team from Silesian University in Poland, and this is our rover, Phoenix 3. It was developed for starting in international rover competitions. It is a fully integrated system ready for field tasks and competition missions. Phoenix 3 is not only a rover, it is a team of people who design, build, test and continuously improve a complete mobile robotic exploration system. Our team operates as a part of the Silesian Phoenix Students Scientific Association, and it is divided into several main sections. The mechanical section is responsible for the rover structure, suspension, drivetrain and robotic arm. The electronics section develops the power system, communication architecture and low-level control. The software section works on the onboard software, vision system, operation interface and autonomy-related solutions. The science section focuses on research-related tasks including geological analysis, sample handling and preparation for science mission during the competition. Each team member has a clearly defined role, but the key element is cooperation between sections. Thanks to this structure, individual mechanic, electronic and software solutions become one integrated platform ready to perform tasks during competition.
We participate in the European Rover Challenge to verify Phoenix 3 in realistic field conditions. ERC also allows us to test our engineering solutions in realistic field conditions, compare them with other teams' approaches, and exchange the experience in areas such as mobility, robotic arms, onboard vision, operation control, and autonomy software. It is also a strong scientific challenge for us. Our science team works on geological data, maps, mission planning, and sample analysis procedures to prepare the rover for tasks inspired by real planetary exploration. For our team, ERC is a way to confirm design assumptions with practice, improve reliability, and develop Phoenix 3 as a complete exploration platform.
Phoenix 3 was designed as a modular and serviceable robotic platform prepared for demanding field conditions. Electronic components are placed in protected compartments to reduce exposure to dust, mechanical damage, and accidental contact during operation. The rover is powered by a removable 6S LiPo battery pack, allowing quick replacement between mission runs. For communication, Phoenix 3 uses a dual-band 2.4 and 5 GHz wireless system, providing a reliable and redundant link between the rover and the ground station. The platform also integrates onboard cameras, GNSS sensors, and perception modules used for navigation, operator awareness, and mission support. Together, this subsystem creates a complete rover architecture, ready for various field tasks.
Phoenix 3 was designed with safety and fundamental principle, both in terms of operational behavior and the reliability of its safety systems. In this test, we demonstrate the rover's mobility together with the procedures and mechanisms implemented to ensure safety operations before and during movement. After receiving the start command, the rover activates its warning light and acoustic signal, while remaining completely stationary for 5 seconds. This gives a clear indication that the platform is about to move. The chassis of Phoenix 3 was specifically designed to operate in difficult terrain, allowing the rover to maintain stable and reliable movement over uneven surfaces and obstacles similar of those expected during competition missions. An important element of the rover safety systems is the physically emergency stop button. When the emergency stop button is pressed, the rover immediately cuts power through a dedicated hardware safety circuit and stops in less 1 second. This solution does not rely on a remote software command. It is based on a physical power cutoff path, making the emergency stop reliable even in case of communication or control system failure.
We are continuously improving the autonomous capabilities of Phoenix 3, focusing on reliable route execution, obstacle awareness, and safe operation in changing terrain conditions. After switching to autonomous mode, the rover changes its warning light pattern to clearly indicate that it is no longer driven manually. Using onboard perception, positioning data, and navigation software, Phoenix 3 is able to follow a planned route and react to obstacles. The generated route map shows the rover path, obstacle locations, and the decisions made by the navigation system. The system is the newest part of the platform and is still evolving. Although it is already capable of moving independently, its sensors, control systems, and safety features are continuously being enhanced to improve robustness and performance.
The drone is our aerial support platform as part of the Phoenix 3 system. It's equipped with control electronics, GNSS navigation, and a camera system that transmits live video to the operators. The main role is to support terrain observation, improve situational awareness, and help plan rover operation during field missions. The flight is performed by a certified pilot, and safety procedures are an important part of the design. In case of communication loss, the drone is able to initiate an autonomous emergency landing. This makes the drone a safe and practical aerial extension of the Phoenix 3 rover system.
One of the key capabilities of Phoenix 3 is precise manipulation during maintenance tasks. The rover is equipped with a robotic arm designed to operate physical interfaces commonly used in technical panels. During the task, the manipulator can interact with rotary switches, lever switches, buttons, connectors, and mechanical locks. The gripper allows us to perform controlled movements with enough precision to insert a power connector into the socket and operate panel elements without direct human interaction. Phoenix 3 is also able to release the electromagnetic lock using the manipulator, which demonstrates the system's ability to complete sequential maintenance procedures. Operations are controlled remotely by operator using camera feedback and the ground station interface that ensure accuracy and safe execution.
During the science task, Phoenix 3 demonstrates its ability to support geological sample collection and analysis in the field. For surface sampling, the robotic arm uses its gripper to pick up a rock sample and place it into an onboard geological sample container. This allows the rover to collect larger surface samples without direct human interaction. For deep sampling, the rover uses a dedicated science module equipped with a drilling mechanism. The system is designed to reach below the surface, collect soil or regolith material, and transfer the sample into a separate container on board the rover. The science module also supports sample mass estimation. Data from the onboard system is displayed in the ground station interface, allowing the operators to monitor the estimated sample weight during the mission. Together, surface sampling, deep sampling, onboard containment, and telemetry feedback allow Phoenix 3 to perform science-oriented tasks inspired by planetary exploration scenarios.
Phoenix 3 is the result of many months of design, development, integration, and testing. Every subsystem presented in this video was created through a combined effort of our team, working together toward one shared goal: building a complete, field-ready robotic platform. For Silesian Phoenix, the European Rover Challenge is not only a competition, it is an opportunity to verify our engineering decision in mission conditions, improve Phoenix 3, and represent the Silesian University of Technology in international rover community.